Dear listener, welcome to my channel. Main topic of this video is indexing and scoring in information system. Subtopic is inverted file index. In this video, these mentioned topics are covered. Now let us start. Searching for basic queries in IR have two options. First is sequential or online text searching. It finds the occurrences of pattern in text when the text is not pre-processed. It is good when text is small in size. In MB, index overhead can't be afforded. Also, text is volatile in nature, that it changes frequently. For example, when we search using Ctrl F option in text documents or web pages, we are doing sequential or online text searching. Second topic is index searching. It builds a data structure over the text to speed up the search. It is good when text is large or huge and the text is semi-static in nature, because when the underlying text is changed, the index which is built on that text is going to be changed. The most successful technique for medium-sized database is to combine online and index searching. Efficiency might seem a secondary issue when compared to effectiveness. It can be rarely neglected in the design of an IR system. Efficiency in IR system to process user queries with minimal requirement of computational resource. As we move to larger scale application, efficiency becomes more and more important. For example, in web search engine that indexes terabytes of data and serve hundreds or thousands of queries per second. Indexing is used to improve the database efficiency by reducing the number of disk access necessary while query is completed. Index is some sort of data structure. It is used to quickly identify and access the data in database table. Now two examples of index shown. One is the index that is used in book. So generally index is present at the back side of the book and it shows the index or key terms and the key terms, the presence of the key terms on a particular page. So for example, if we want to see any particular keyword, for example ABC, we can easily find out that ABC information is available on 164 and 321 pages. So we can quickly go to that particular page and see the information on ABC. That is, it is easy to locate the information from the huge amount of data. For example, in database, the search key, now you make the assumption that it is primary key, and here the particular pointer to disk locations are given. So when the words comes between Alice and David in chronological order, the disk number 149 is accessed. When it is between David to Greg, that 2459 is accessed, and after that 336 it accessed. So in this way, indexing is used for effective retrieval of the data. Index is a data structure constructed from text to speed up searches. In the context of an index-based information retrieval system, the system's efficiency can be measured by time, indexing time, that is amount of time required to create the index. Indexing space, the space is used during index generation. Index storage, the amount of space required to keep the index. Query latency, the amount of time that passes between the arrival of the query and the development of the answer. And query throughput is number of queries executed per second. So these points are very much important when we are going for indexing of a data. When text is modified, an index that was created on it must also be updated. Current indexing technology is not prepared to handle frequent changes to the text collection. Semi-static collection are those who are not updated on regular basis. Most real text collection including the web are semi-static in nature. For example, while the web updates rapidly, search engine crawls are relatively slow. Incremental indexing is required to maintain the freshness. So depending on the nature of the data, we require to make the decision how to make the indexing on that particular type of data. Just like in our traditional relational database, searching for data may be costly. In a RDB, one can take advantage from the well-defined structure on the data. Linear scan of the data is not feasible for non-trivial data set. Now when we are using relational database, it has a particular structure and we require to keep the data in that particular format, that is nothing but row and column format. But in IR system, rarely text is structured format, the text is unstructured format. So we are not going similarly like the indexing which is used in RDBMS. Now if we are not using the indexing, we require to go for the linear scan, and which is not feasible option for non-trivial data set. And when the text is unstructured and we require to make the indexing, we require to think of other options, and that options are nothing but inverted files, suffix arrays and signature file. So these are the three methods which mainly used for indexing for IR system. Traditional indices are also there like B trees, but they are not suited for the information retrieval system. In IR, following are the popular ways to create an index. First is inverted file. It is a best choice for most applications because it is simple and easy. Suffix arrays and trees, faster for phrase search but hard to build and maintain. Signature file, word-oriented index structure based on hashing concept. It was popular in the mid 1980, but inverted file takes place over a signature file because inverted file is very easy compared to signature file and simple and easy to maintain. For each techniques, we require to give the attention that is search cost and space overhead, because when we are going for indexing, at that time we require the space, and at the same time we should have that trade-off between the retrieval and the maintenance of the index, construction cost and maintenance cost. Index should be built and stored in data structure before searching. So this is the work when IR system is built. So initially when database or data set or set of documents is set, at that time we require to do indexing before designing of the remaining of the IR system. That is nothing but the retrieval model. Basic data structures are sorted array, binary search, B trees, hash table, trie, Patricia T. Now trie is used in inverted file. So trie is from retrieval. Multi-way trees that store a set of strings and able to retrieve them in linear time. This is very important. Every edge of the tree is labeled with letter. For storing strings over an alphabet used in dictionaries. For example, this is a simple trie structure. Now here we can get, this is same as like DFA, that is deterministic automata, act, action, and apple. It is represented by this structure. So similar structure we are using in the inverted file. Similar structure we are going to use in suffix trees and suffix arrays. Inverted files. Inverted files or inverted index is a word-oriented mechanism for indexing a text collection in order to speed up the searching task. There are two main elements: vocabulary, that is set of unique terms, that is nothing but keywords, and occurrences, that is location where those terms appear. The occurrences can be recorded as terms or byte offsets. Using term offset or word or character is good to retrieve the concepts such as proximity, whereas byte offset, that is character position, is to allow the direct access. So in the example it would be clear that how we are doing the inverted file using term offset and the byte offset. Now this is example of byte offset. Now the text is, this is a paragraph. A paragraph has many lines. Every line has many words. Words are made from letter. Now here every occurrence of the particular character, the number is given. So in this way the T is started with 1 and last character is dot, which comes at the 103. Now here whatever that particular word which is started is mentioned in the yellow. So here for simplicity stop words are removed. So whatever the important words, they are represented with the yellow. So they are nothing but the starting, and here byte offset is used. So every character is given a particular number. It is also full inverted indices. Stemming is compulsory required, otherwise difficult to locate exact appearance. So here for simplicity stemming is not given, but generally when we take a document for indexing, generally we perform the stemming operation and stopword operation to do the fast searching. But when we do the stemming and the stopword removal, at that time phrase finding is also become very difficult. So we require to take decision according to the convenience or the retrieval rate. Now to create a inverted file index, first we require to remove the keywords, perform the stemming operation. Here for simplicity, stemming operation is not shown. Now paragraph, many, line, words, made, letters, every. This is the words they are considered, and others are the stop words. Now we require to write down these words in a chronological order, that is a dictionary order, that is nothing but sorted. So it is ascending sorted. Every, letter, line, made, many, paragraph. Now we require to find out the occurrence, that is byte offset. So every word occur at the 49 location, letter word occur at 96 location. So in this way we are storing the vocabulary in sorted order and their occurrences. Now here the stop words are this, is, a, has, are, from are not considered, and here stemming, that's why we are showing for line and lines we are showing the same location. That's why the lines is equal to line. For example 42 and 55, we can see that 42 lines word is there and next is 55 line is there, so they are mentioned as the same. Now in inverted file index, words is equal to word, lines dot equal to line, paragraph dot equal to paragraph, but this is not case for the inverted suffix arrays and suffix trees. In suffix arrays and suffix trees, lines dot is not equal to line. So in this way we are creating the inverted file index based on the byte offset. Now this is the example for inverted file index using the term offset. Now here only the important words are taken, stop words are removed. So first word is paragraph. So paragraph is the fourth word. Now this is a paragraph. Paragraph is the fourth word. Then paragraph is again at the sixth location. So sixth word is again paragraph. So in this way we are not storing each byte offset, but we are storing the words or a character. That's why it is called as the term offset. So it is good to retrieve the concepts such as proximity, so we can easily locate. So in this way also we can create the inverted file index. The number of index term is often several orders of magnitude smaller when compared to document size. The space consumed by the occurrence list is not trivial. For example, this is a very small file that is only of 2 to 3 lines. Then here we can see that even for large documents this vocabulary is very much limited, but this number of word occurrences, they are having the big train of particular location. The space consumed by the occurrence list is not trivial, but by the vocabulary is trivial. Each time the term appears, it must be added to a list in inverted file. That may lead to a quite considerable index overhead. Space requirement. The space required for the vocabulary is rather small. According to Heap's law, the vocabulary grows O n raised to b, where beta is constant between 0.4 and 0.6 in practice. For instance, for trace 3 collection, the vocabulary for 1 gigabyte of text occupies only 5 megabytes. So that's why the vocabulary is limited, because it contains only distinct word from the from the document, and also after removing the stop word and stemming operation, it reduced quite. This may be further reduced by stemming and other normalization technique. Now in inverted file index we can go for the block addressing, that is for efficient space management. The occurrence list requires much more space, because whenever that particular word appears we require to write down that particular byte offset or the character location or the word location. So 40% of the text size if stop words are omitted, and 80% when stop words are indexed. So that is a better option than to remove the stop words. To reduce space requirements, a technique called block addressing is used. In block addressing, the text is divided into blocks. The occurrence of the points to the block where the word appears instead of exact position. Block addressing is a method used for accessing the text in which text data needs to be readily available at the time of searching. So when we are going for block addressing, at that time that text should be readily available, otherwise it's of no use, because by getting only block we can't do anything. Advantage: the number of pointers is smaller than position. Then all the occurrence of word inside a single block are collapsed to one reference. So these 2 points will be clear, or 3 points will clear with the example, and much small overhead. Now see, this is the first example, and after that we can go for the disadvantages. This is a paragraph. A paragraph has many lines. Every line has many words, and words are made from letters. Now we make the paragraph in which we are keeping the first 4 words. So block 1, this is a paragraph. Then a paragraph has many, then lines, every line. So in this way we have created the 5 blocks, and in all blocks we are keeping the 4 characters. So it may happen that in the block 5 the minimum or not exactly 4 words will come. Now here same we are keeping that, and here instead of that occurrences we are writing just block number. So for example, every is coming in the block 3, then many is coming in the block 2 and 4. So in that way we are not writing that particular byte offset or the word number, but we are writing that particular block. But only here we are getting the block number. To search inside we require to go for the online text searching. Block addressing advantage. For example, a document has 1,000 words. Now 10 blocks are created to hold 10 blocks are created to hold 100 words each. Let X be a keyword is present at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 800, 900. For simplicity, term offset is considered. Now here this is nothing but the X location. So X occur at 10th location, X occur at 20 location. Now if we see, and if we are using the normal inverted file index, what will happen? We require to write down in the vocabulary X, and after that we will write down 10, 20, 30. So long train of that occurrences occur. So if we use the block addressing, so that we are going to write down only block entries for X. So for X it will present in the first block because 100 words, so it will present in the first block, then in the second block, 8th block and 9th block. So entries of the keyword X will be only 4 location, 1, 2, 4, 8. And if we are using normal inverted file indexing, we require to write down all this location. Otherwise by simple inverted file indexing, occurrence list will be longer. For binary retrieval model, this is very important to understand. For binary retrieval model, we need to check only vocabulary for presence of term. There is no need to go for that particular block. But for other retrieval model, for example term frequency or proximity queries, we need to check the block entries for the term frequency or that particular order of the words. Disadvantage of block addressing. This approach is not suitable for scenarios involving remote text such as web search engine or situation where the text is stored on CD-ROM that must be mounted. However, for certain queries that don't require exact position of the terms in the text, for example binary model, block addressing can be still effective, because by this way we are just getting the information that this particular keyword is present in the block. But when we don't require that count, then at that time or particular order, at that time this block number is also sufficient. But when we require the exact matching, at that time there is need that this text should be readily available of that particular block. So that's why this will not work for the remote location. Online search over the qualifying blocks if exact position are required, that is phrase or proximal queries, query in double quotes. Phrase occupies the multiple block entries, so here the block addressing is not suitable. For example, the query is flowers are beautiful. So flower is in block 1 and beautiful comes in a block 2. Now only presence is not sufficient because we require to see that complete string. Even for simplicity we assume that R is a stop word. Now we require to find out that order flowers beautiful. We don't want beautiful flowers, but we want flowers beautiful. Therefore linear scan of both blocks is required to find out this particular appearance. Even if it is present in block 1, we need to do linear scan to find the phrases. So even if flowers and beautiful are present, and if we give the query in double quote or we give the phrase query, at that time again we require to first locate the block, and in that block we require to do online search or sequential search to find out that particular pattern. Now see this example. That house is a garden. The garden has many flowers. The flowers are beautiful. So our query is flowers are beautiful. So we can easily locate that flowers and beautiful are present in 4th block, and then flowers in 3rd block and beautiful in the 4th block. So even block 3rd and 4th matched, again processing is required for matching of that particular string. Now block size can be fixed or variable. Blocks can be of fixed size or variable size, that is nothing but natural cuts. Fixed size, it improves efficiency at retrieval time. Variable size, that is natural cut based on the natural division of the text. So natural division of the text may be files, documents, web pages or other. So we are not creating the blocks of fixed size when we have the web pages. So we can make one page as a one block, then one file as one block. Based on that our collection of the data. More variance in the block size, the more amount of text is sequentially traversed on an average, because when we may write the algorithm on fixed block size, at that time algorithm is also very simple and the amount of text sequentially traverse on an average, because at most we require to traverse whatever the size of that particular block. This is because the larger block matches query more frequently and more expensive to traverse. For example, we go for variable size. Now see this example, document of 2050 words, and we make the blocks. In first block we keep the 50 words and in the second block we keep the 2000 words. When we do the search for the particular text from this document, most of the search will fall in the big block because maximum character will match in the second block, which is of 2000 words. So if only presence is required of key term, it is beneficial, but for proximal queries we may require to do linear scan over 2000 words, so which is not beneficial. Variable size may eliminate the need for online traversal if one block per retrieval unit is used and only to check the presence of that particular keyword. For example, if one block per retrieval unit is used and the exact match positions are not required, there is no need to traverse the text for queries, because only we require that presence is there or not. If many retrieval units are packed in a single block, then block has to be traversed to determine which units to retrieve. For example, if we have 10 web pages and if we make one web page as one block, so at that time it is variable because every web page don't have the same length. But here when we are finding out the particular occurrence, we can check only that block entries of 10 web pages. But if we combine 5 web pages in one block and 5 web pages in another block, at that time to find out that again we require to check that 5 web pages internally for that particular block. So that is the problem. So for example, if we book scan in soft copy and having 6 units, if we use fixed size, then we can decide how many words in one block. But for variable size, we can take each page as one block or each unit as a one block according to our convenience. For web page collection, we can take one page as per block. So based on our data collection, we are going for variable size or the fixed size, but only when presence is required, variable size is a good option. So these are the references for this video. Thank you.